Okay, today we are doing 2 quick lessons on simplifying rational exponents or exponents with fractions. And we're also going to work on the distance formula. This is the last section that we will be covering for chapter 11. All right, so when we look at x to the 1/2 power, when you see that 1/2, x to the 1/2, what this is, in the denominator, we're really talking about the root, and in the numerator, it's really the exponent. Okay? So, what this really means is when I take the square root of x, right, we put the root in the little v part of the square root sign. So that would be this would be a square root, and it's to what power? First power. The exponent is to the first power. So if I'm doing the next one, x to the 1/3 power, what kind of root is it? Yes. It's a cube root, and x would be to what power? To the first power. Now what that means is what number times itself 3 times gives you what's under the radical. So if I had x to the 1/4 power, what does that mean? Aiden?
Quadruple radical.
You could say the fourth root
of
x
to the first.
Perfect. You guys get the idea? Okay. So how would we write the first one? Well, let's show an example first. So if I'm doing 8, really I'm putting 8 under the radical, and it's a cube root. So what number times itself 3 times, Natalia, equals 8? A number times a number times a number equals 8. Same number. 2. The cube root of 8 is 2. Right. This time, it says, what kind of, yes?
Is the fraction the exponent?
The 2 in the denominator is the kind of root.
The 8 to 1/3, that's the exponent, right?
That's the exponent, the 1/3. And so in that exponent, the denominator represents the root, the exponent represents the power underneath. Okay, so what would the next one be? What am I putting under the radical? Let's go, Caesar. What do I put under the radical? 16. What goes in the little v? 2. And what is the power, the exponent under the radical? No. To what power here, under the radical, right here? Nope. This is the 2. You already told me that the 2 goes here. Right? I want to know to what is the power of the 16. One more time. When I had x to the 1/2 power, this is the root, and this is the exponent. 1. So that would be to the first power. And what is the answer, Caesar? 4. Okay, you guys try the next 1, 2, 3, 4. Go. Pause the recording. Okay, hold on. I do expect you're showing me the work that I'm showing here. Okay? Put it under the radical. So what is the 4th root of 16? What did you say?
I got 2.
2. Good. Next one. What is the 4th root of 81? McKenna?
3.
3. Okay. What is the 5th root of 32? Let's go. Karoni? 2. And what is the 3rd root of 125? Ellie? 5. 5 times 5 times 5. Got it? So these are pretty easy. Let's move on to... Okay, so roots of negative numbers. Now, can we take the square root of a negative 16? No. So we would say no real root. It can be imaginary, but it can't be. But if I have can I take the negative cube root of negative 27? What?
It says negative 16. Should there be a root 2?
It is this. It means what times itself.
Oh,
Okay, with square roots, by the way, guys, when we write, you've been noticing, we've been doing radicals like this, right? It's assumed. It's kind of like 1, that there's a 2 there. If you don't write any number, it's assumed that there is a 2 there. So I'm glad you brought that up. Okay, so what would the cube root of negative 27 be?
You can multiply 3 by 3 by 3, or 3 by 3 by negative 3.
No, it has to be, what it means to be a cube root is exactly the same. Ethan?
Negative 3?
Yeah, it's just negative 3 because why? Because negative 3 times negative 3 times negative 3. So you can have negatives with odd roots. Does that make sense?
yes.
If you have an odd root, you can have a negative. If it's an even root, it can't be negative. So what would we say for number 3? Yes.
Negative 2.
Negative 2, that's correct. It's an odd root. Not the base, but the root. Because it's 5 negatives, so that's okay. It's to the 5th power. I said an odd root right here. Odd root. If it has an odd root, the base can be negative. Yes, question. Okay, next one. Let's go. Negative 81 to the 1/4 power. Natalia?
No real root because the denominator, the 4, is even.
Even. You can't have a negative number. Does that make sense? Okay, let's move on to writing using a root. Okay, so isn't this basically what we were doing before? Can't do it. This is more of the same. Can we do this one? Yes. It's negative 2. Why don't you do the next 2? Go. Pause the recording. Okay, now check your answers. Number 3 was no real root, and number 4 was negative 5. Now pause the recording and do the next 4 on your own. All right, let's check our answers. So number 5, let's go with Leah. It's negative 2. The 5th root of negative 32, we can take a negative if there's 5 roots. It would be negative 2. Number 6, the 1/6 root of negative 64. Amanda Miranda? That's correct because it's an even amount. We can't do that for a negative base. Number 7, negative 128. Dennis?
That would be negative 2.
To the 7th root is also negative 2. Good. And then the last one, negative 1,000. Matthew? Negative 10. Good. To the negative 1,000 to the 3rd root. Okay. All right. So now here we go. Let's add a little bit more to it. We know that n is the root and 1 is the power, right? We can write it like this, or we can also square it after. We don't have to square it underneath. We can square it after. So when you have something like this, it doesn't really matter if you take the root first or the power first. I don't even like to do it like this. I really like to. So, well, I guess at times you can do it too. So it's 2 times the 1/3 root, right? We can square it afterwards. That would be, so if we know that 8 to the 1/3 power is 2, then I can square it in the end. Does that make sense? We know that 8 to the 1/3 power is 2, so we can square it in the end. Or to the 2/3 power, we can square the 8 first and then take that number to the 1/3 power. Does that make sense? What number times itself, it will work out to be the same thing. So it doesn't matter really what you do first. I always like to do it like this. Oops. I always write it out as what kind of, it's a square root, and it's 9 to the third power. Now, I might not want to do 9 to the third power because it's big, right? So in this case, I'm probably going to do this. I'm going to square it after. So what is the square root of 9? 3. And then cube that. Cube that. What is that? 27. Does that make sense? So you could take the power first underneath the radical or the power after. Okay, let's do 27. What is the root? What's the root? 3. And it's, what's the base? What's the base? 27. Do you think it's going to be easier to square it underneath or square it afterwards?
Square it afterwards.
Yep. So what is the root of the cube root of 27? 3, and then I have to square it. So it is 9. You guys with me? Okay, the next one. What is the root?
25.
2. What is the base?
Base is 25.
And we can square it afterwards. So what do we get? 5 to what power? Which is? Okay, you guys do the last one. Pause it. Okay, what root is it, Andrew?
The root is 4.
Okay, what is the base?
10,000.
And then we have to do what power?
To the third.
Good. What is the fourth root of 10,000?
10.
And then to the third power, what does that equal?
1,000.
Perfect. Get it? Okay. All right. Do you feel like you have this?
Yeah.
Okay. Can we move on to the so if I put any of these on your test, you could be okay with it. Okay. I want to move on to the distance formula. So we're going to pause it so I can get there. Graders. Use the distance formula to find the distance between 2 points on a coordinate plane. So we can, do you see how we can make our own right triangle? Yeah. So we can find the difference in the y values here, that's the height, and the distance in the x values here. So if I call this, let's say we call this, that is how many units? I'm going from 4 to -2, right? To find the distance, wouldn't I take the height of 4 and subtract, since I'm finding the difference in it, of -2? And what does that equal to? 6. 6 units. Do you understand? To find a difference, we take the first number, subtract out the lower number. Okay? This is actually like one of our sides. To find the width, what am I going to do? The difference between one x and the other x. Do you understand? So one x is a 3 and the other x is a 1. I'd probably start with the higher one. Isn't it 3 minus -1? So if we take both of those distances and we square them, are you with me? Look at the PowerPoint, Natalia. If I take both of those distances and I square them, we can say that this is a distance of 6, right? 4 minus -2 is 6. 6 squared, and this distance right here is 3 minus -1 is 4 plus 4 squared. That should give us a hypotenuse to this right triangle we have created. Does that make sense? Which is what? Let's just call it x squared. We don't know what the diagonal is. Right? So 36 plus 16 is 52. If we root both sides, we can estimate it to about 7.2. Are you guys with me so far there? Yes or no? Natalia? Do you understand what I've done? Okay, so we can really kind of take this and create what's called the distance formula. Okay, let's call this x1 and x2. You should start taking your notes now. Okay, we're doing y2 minus y1, and here to find the distance right here is x2 minus x1. Okay? You can just write the overall formula. So, here it is. Distance is equal to the square root of x squared minus x1, x2 minus x1 squared plus the quantity y2 minus y1 squared. So here's the formula one more time. We always start with it, and I want you to write it for each homework problem, or you won't remember it. So if given 2 points, such as -1, -2, and 3, 4, they can give it to you on the graph. The first thing you're going to do is name your points. Let's call this x1, y1, x2, y2. You with me? Now what do I substitute? D is equal to, I go inside the radical. What is x2? Everybody? 3 minus -1. Close it up and square it. Plus, what else? 4 minus -2. Close it up and square it. Okay? 3 plus, this is the square root of 4 squared plus what? 6 squared. So what do we get? Which equals the square root of 52, which is about equal to 7.2. Yes?
Since it's squared on both of them, couldn't at the beginning, you just take them out of the radical, so then it would end up being like...
Well, you're going to root it eventually. Didn't we root it eventually? Why do we need to take it out when we have to put it in eventually? I'm teaching you how to use a formula. Okay, when I just did it before, we got to the exact same thing right here. Didn't we eventually root it? So instead of in the end rooting it, we're starting out with a formula. So what I'm doing is teaching you to use the formula. It's not optional to do it another method. It is a method that I am teaching you. Am I clear?
Can you go back?
Okay, I'm going to pause it. Okay, we're basically doing the same thing. I don't know why it turned off there, so I hope you're okay. So this is using the distance formula. Now, let's go on to try it. The first thing we're going to do is start with our formula. I want you writing the formula every time, or you will not remember it for your test. Don't try and remember it, memorize it. So let's go. Let's call the first one, you should be writing what I'm writing. x1, y1, x2, y2. So what am I substituting inside? What are we substituting inside for the first, for your x's? Negative what? 6 minus -4, and we're squaring it, plus negative 2 minus 5 squared. So no matter what, because it's squared, since d is the same, I don't need to keep writing d on that side. It's assumed. So the square root of what? 6 plus 4 is what? 10 squared plus negative 7 squared. What does it simplify to? The square root of 100 plus 49. The square root of 149. Now let's estimate. Okay, 149 is... Okay. Okay, 149 falls between 144. Did you say 12.6?
No, we said 12.16.
Yeah, okay, so this is 4 digits and this is 20. I could say 12.1 or 12.2. 12.1, that's about right. Second, I'll double check. Clear. Okay, why don't you guys start the next one? Second radical 149. 12.2. So we were good. It's okay. That's not bad. 12.166 is 4/10 off.
No, 400.
4/100 off, sorry.
You could round
12.
to the nearest tenth, and it would be 12.2.
Yeah. I said I'm okay with you guys being... Okay, I want you to try the next one. Go. I'm going to put it up the PowerPoint. All right, so let's check our work. I'm going to use the formula. X squared minus x1 squared, the quantity squared, plus y2, the quantity of y2 minus y1 squared. Substitute in, and you should have gotten the square root of
Like 17 points.
298. No, that's 289. Oh, yeah. Yeah, I thought you were... Okay. Yeah, 17.3. Perfect. Very good. All right, so let's look at how we're going to see this. Let's look at how we're going to see this. We only have a couple minutes left, so we probably won't have time. They might give you just 2 points on a coordinate plane. Find the ordered pairs, and you can use the distance formula. Does that make sense? Hold on. Okay? All right, so we might be given just 2 random points. Any 2 points on a coordinate plane. All right, so just 2 random points. Use the distance formula. You can find the ordered pairs, name them, and use the distance formula. Something like this, very typical of an SBAC or a standardized test. So instead of drawing 3 right angles from each diagonal, we can use the distance formula for each point. So from A to B, we can use the points there. Does that make sense? From B to C, we just use those ordered pairs. And then from A to C, line AC, line segment AC, right? We're just using those 2 ordered pairs in the distance formula. Do you understand what I'm talking about? Yeah. Okay. Let's see. Determine whether the points 3, 4, 5, 1, and 2, -1 are vertices of a right triangle. So you have to plot them. And of course, they're not going to make it easy for you. And you're going to have to take okay. Well, it appears to be, but you're going to need to, what do you think would be the hypotenuse? D1, right? Looks like it's the biggest side, and so you substitute the points in. D1 is radical 26, D2 is rad 13, D3 is rad 13. Let's see if it works in, so 13, okay, it would be 13, 13. Yep, it's a right triangle. Okay, do you understand? This is really, I think this is the last problem. So, questions about the distance formula? No? Questions? Okay. All right, that's it.